we are going to look at a special function called the wrapping function. And what it's going to do is take a point, take any number and map it to a point on the unit circle. I'm going to go ahead and try and draw this in a way that hopefully is a little bit kind of easy to understand what's going on. So we've got our unit circle here, and what we're going to do is we'll pick numbers, and I'm going to draw a number line, and the number line I'm going to draw is I'm actually going to draw it over here. I'm just going to go right up into that definition box there. So we're going to say this is a number line here, okay? And this number line, this is the positive side, and this is the negative side, and right here is 0, okay? And so as we go up, we'd count, on 1, and 2, whatever, and so on. And if we take this line and we wrap it around the circle, okay? And technically it would just wrap forever because the number line goes on forever, so it would wrap all the way around, just keep going. Then we get something like this. So like this point 1 here, if I pull that down, okay, then it would create a point, down here. Okay, if I wrap it down. And so this segment from 0 to 1, I could think of as that piece of the circle. Okay, so this point 1 would map then to this point right here. And that point we're calling the P, the point XY. Okay, so the wrapping function, which we have W, takes a number and sends it onto a point on the unit circle. Now, what's really nice is this function. It may seem complicated, but actually, all we're doing here is, because this is a unit circle, and we know that the arc length of a portion of a circle is r times the angle. The unit circle has a radius of 1. So we actually have S, which in this case is this curve right here. S is equal to 1 times theta. Okay, where theta is the angle in standard position to that point. Okay. Turns out that angle, that's the radian measure, and it has the exact same value as whatever number on the number line we used to wrap onto the circle. So this gives us a very nice way to plug in a number, take a number and find a point on the circle that corresponds to that number, but the number turns out to be simply an angle in radian measure. Let's go ahead and look at an example. We want to evaluate the wrapping function of pi over 6. And really all that is saying is, again, let me draw a picture here. We have the unit circle. And the unit circle, the wrapping function takes a number and sends it to a point on the unit circle. And this number, pi over 6, turns out to be the same thing as the angle in standard position. So pi over 6, I'm going to go ahead and say that pi over 6 radians in degrees, we can get by multiplying by 180 degrees over pi. And that gives us 30 degrees. It's a 30-degree measurement. So I'm going to go ahead and draw that. Okay. So that right there is the angle. This is the point that this wrapping function sends my angle or number to. And I just want to know what that point is. That's what the wrapping function is. So I think about what I have here, and I've got a little triangle. If I connect that down, and I've got this angle right here. I'm going to go ahead and write it as 30 degrees. So a little bit less cumbersome to write. And that makes this up here 60 degrees. So this is a 30, 60, 90 triangle. Now I'm going to look over separately. Normally with a 30, 60, 90 triangle, we have some nice relationships. Generally, from our 30-degree angle opposite, we'd write 1, and the hypotenuse we'd write 2, and then this other side, square root of 3. However, in this triangle, the hypotenuse is a radius of this unit circle, which means I know that that is a length of 1. So I've just scaled this triangle down to get this triangle over here. So to get that, we're just going to, I can see from 2 to get to 1, I just have to divide by 2. So we'll divide each of these by 2, and that would be the length of these sides. So I'd have the square root of 3 over 2 here, and 1 over 2 here. Now, why did I care about that? Well, this point right here is an x and a y. That's the point I'm looking for because the wrapping function is equal to a point, okay? And I'm looking for this x and this y, and it just so happens that x and that y is this horizontal distance and this vertical distance. And so my wrapping function of pi over 6 is equal to the point. The x-coordinate is this horizontal distance, square root of 3 over 2. And this y-coordinate, this distance, which is 1/2.